In this problem, I have to use the graph of the function f prime. So this is the graph of the derivative to determine the intervals on which the function is increasing or decreasing, and I have to estimate the x-coordinates of all my local extrema. So if I have a function different than what I'm drawing right here, this is my, let's call this my function f. My derivative is increasing here, it's 0 there, and it's negative there. I'm sorry, my derivative is positive here, 0 there, and negative there, and 0 there, and positive there. So that's my derivative. So what I'm saying is this. This is the graph of my derivative. My derivative is positive right here from negative infinity to 2. If my derivative is positive, that means my function is increasing. So I already know that my function is increasing where my derivative is positive, so it's increasing from negative infinity to negative 2. Where else is my derivative positive? My derivative is positive right here. So it is also increasing from 0 to positive 2. My derivative is negative from negative 2 to 0. So it's decreasing from negative 2 to 0. And it's also decreasing from 2 to infinity. Now, so what are the x-coordinates of my local extreme values? Well, an extreme value happens when my slope goes from increasing to decreasing, or from decreasing to increasing. Well, at negative 2, I'll use different color here. At negative 2, my function went from increasing to decreasing. And at positive 2, my slope went from increasing to decreasing. So right here, where the derivative is 0, it went from increasing to decreasing. It also went from increasing to decreasing right here at 2. And it also went to increasing to decreasing right there at 0. So my local extrema are going to have x values of negative 2, 0, and positive 2. Those are the places where my slope changed. So here my slope changed from positive to negative. Here my slope changed from negative to positive. Here my slope changed from positive to negative. So I can actually tell you that this one here is going to be a max. This one here is going to be, so from negative to positive, a min. And from positive to negative, another max.